really happy to have you all. So I'm going to go ahead and we're going to just share a bit for the next couple of minutes while we're letting people in. I'm going to share just a little bit about who We Robotics is, who the Flying Labs are, what we do, and how it all works and comes together. So we are a social impact organization that does bring together local experts and activists to offer alternative systems dominated by foreign-led and top-down interventions. We focus mainly on, of course, supporting local. We, of course, want to focus not only on robots, but we want to focus on the technology that's developing. And that includes the local drone data and robotics leaders in Africa, Latin America, and the Asian Pacific. So the role of We Robotics, and I am kind of going through this quickly because I want to spend as much time as possible with James from AV. But the role of We Robotics is co-creating and facilitating the Flying Labs network. We do technical capacity training, technical transfer, knowledge exchange, and we want to really focus on sustainability and capacity strengthening, monitoring, evaluation, and learning. And then we also want to provide a network model that improves the network and then also allows for better documentation of our use cases and our projects within the drone ecosystem. So Flying Labs, We Robotics enables the Flying Labs to be able to really really support and show that these Flying Labs can be a part of the global network, supporting the power of local. And what Flying Labs does is it demonstrates that support and how locals can have this type of technology and also be independent. So Flying Labs strengthens local experts with expertise in the use of drones, robotics, data, and AI for positive social impact. So Flying Labs are set up and financed. So in line with the network's purpose, Flying Labs are self-financed. They also are hosted by existing local organizations. Flying Labs remain financially independent by offering their own training and professional services to local governments, businesses, NGOs, etc. So they also work a lot with internet by supporting and enabling each other to help more people around the world. So I'm so excited to have James Middleton from AV. He's going to be sharing about the AV drone that they just used in Botswana. And it's really exciting to have him. He's from South Africa, living in Amsterdam. And so he has been working with AV for the last year. And we're really excited to have him explain and share some of the use cases that they just accomplished flying in Botswana around the whole country. AV primarily serves Europe, and they are exploring opportunities in Africa. So I'm excited for our African Flying Labs partners to also learn more about the AV drone. And then they also they focus on cutting edge drone technology, which is something that we're all continuously learning about throughout our careers and as we work within the network. So really happy to have you, James, and thank you so much for joining us today.
No problem. Thank you for having me. Let me share my screen in a second. You should be able to see that. So thank you so much for the invite and thank you for the opportunity to talk. As Elsa said, my name is James. I'm a South African. I've been living in Amsterdam for about a year now and leading the business development here at AV. In putting this presentation together, it was interesting to try and work out what exactly to talk about, because I could talk about AV, I could talk about what we do here, the kind of technology we develop. I could talk about our customers here in Europe and what we're trying to look to do from a European context. But then also, as mentioned, as Elsa mentioned, we want to fly all over the world, and we want to have our aircraft all over the world. And Africa is one of those places where it is easier for us to do so for a host of reasons. It's relatively close by, time zone, etc. We have African people working at AV, but also it's also one of the places where we can have one of the largest impacts, and that is also at the core of what we want to do. So the presentation will be a little bit of both. It'll be trying to explain who we are as a company and what we do, that then should lay the context for what we did in Botswana and what we were trying to achieve, what we learned. And at the end, if there are any questions, please just type them in the chat as we go along, and I think there will be more than enough opportunity to answer those. I will try to also get the right balance in terms of things that are relatively technical, things that are more anecdotal, etc., to try and make it as engaging as possible. So please don't hold back from asking any questions that you may have. So just to start with AV, we were founded in 2016, and we are a drone manufacturer, and we are interested mainly in manufacturing. And the reason I say that is we do not really see ourselves or want to position ourselves as an operator. So we don't want to be flying drones all over the world. We want to have our drones all over the world being flown by different companies. So that is a very important fact to note in this. So for us to go and fly in Botswana, we obviously can do this, but it's not our core business, and it's not who we really are. We're based in Amsterdam, which means that we operate in very specific conditions here. It's a lot of rain, a lot of wind, sea level. So to go and fly in a place like Botswana, where we are high, it's hot, it's dusty, it gives us a lot of excellent data for our engineers to work with. And we are about 50 people at the moment. I would say 70% of that is engineers or software developers who are building the technology that we develop. To give you a sense of what we do, so we are in the business, or have the goal of building autonomous integrated aerial networks. So we want to build these drone networks that work in 3 different use cases. You can see in the bottom right there. So we want to be developing technology that does medical logistics, drones that deliver blood bags, vaccines, medicines all over the world, or we want to be working with emergency response, being able to respond to a fire, a traffic accident, anything like that rapidly and quickly. Or in the case of large infrastructure, like ports, like the Port of Rotterdam, we do weekly flights where we are doing inspection and monitoring around those locations. And the important aspect of that was, you can see the diagrams, it's all based on a network. And so we believe that with a network, you can be more autonomous. You don't need people to run a network. You can achieve more. Our drones are electric, so there's minimal carbon footprint. You can be incredibly efficient by having drones located in the right places, and then obviously being able to respond quickly, particularly in that emergency response use case, is very, very important for us. So those are the 3 applications that we work within, and that kind of explains what we do in the sense of manufacturing. To really make it a lot more concrete in terms of our solution, we develop 3 categories of technology. The first and most important is our aircraft. And we have developed the Era 3, which is what we took to Botswana and what I'll talk you through. And so that is the actual drone itself. It's relatively large. It's 2.5 meters wide. It can weigh up to 19.5 kilograms. It cruises at around 100 kilometers an hour. And has if you're in Amsterdam, at least a max range of around 100 kilometers for 60 to 75 minutes. On the aircraft, we've developed 2 payloads, each suited for the different use cases or applications that I showed you. So we have the camera, the air-aware camera, which basically gives you the visuals that you need for an emergency response use case. And then we also have what we have called the Air Care Med Kit, which is a specially designed temperature-controlled kit that enables you to transport the bloods, the vaccines, anything like that within that. So that's the drone side of things. When it comes to the network, the next most important part is what we call our ground infrastructure. And so what you can see in this image on the right is our docking station. And the best way to think of that is it's a miniature hangar that basically looks after the drone. It keeps it basically safe from the weather. Soon it'll be able to automatically charge the drone. You can operate it, open and close it remotely. And it even does that on that disc there. It will spin the drone into the wind for maximum takeoff efficiency with that. And then along with that comes a control tower, which you can't see in this image. It's effectively a little tower that stands next to it that provides you with weather data, visuals, and the LTE connection that the drone uses to fly. And lastly, the software that we have developed. So that's the third part of what we do. Obviously, the drone has a brain, and it's an autonomous drone. So there's a lot of technology that's gone into that drone. But then there is flight operations software that the pilots use to actually create those missions, upload them to the drone for the drone to then complete those missions. And then the last part of our software is the fleet management. So we see a world where our customers own multiple drones, they own multiple docking stations in that network setup, and they can control all of that through that software. So that would be the best way to describe what we do. We develop aircraft, the ground infrastructure that supports that, and then the software that links all of that together. I think an important thing to also say within all of this is this is geared to be, we are able to do this and operate these drones remotely. So even though we took a crew over to Botswana, we actually have in the room next door a control center where we can fly our drones in Dubai, we can fly them in the port of Rotterdam, etc. So it's also possible as part of that autonomous and that efficiency model to be able to do this all remotely. When it comes to going to Botswana, we managed to get there in the first place through a wonderful company that approached us called Drones for Africa. And Drones for Africa are based in Gaborone, and they approached us around these demonstrations. And just to give you a bit of context as to who they are definitely one of the leading drone operators in Botswana, and they have multiple areas of speciality or expertise. So that's agriculture, construction, training, and consulting. They also do the sales and the maintenance for various different types of drones, various different applications, as I've mentioned there. And something that we learned is that the CAA, the Botswana CAA, the Civil Aviation Authority, are very, very close to Drones for Africa. And the partnership was very, very impressive to see in terms of how they worked together and enabled us to actually do all of these demonstrations. I think, if I'm not mistaken, it was the first time that Drones for Africa have ever worked with a drone that can do beyond visual line of sight flights. So that was also really good to see them pushing that forward in this context. And I cannot speak highly enough of them in terms of how good it was to partner with them. And definitely, it's only a matter of time until you see them flying AV technology around Botswana very, very soon. So to put it into context, they effectively designed the entire trip that we had in Botswana. It was a 2.5-week trip, and the 3 different demonstrations that we did there, and we certainly couldn't have done it without their support. So to now get to the details of what we did. We went to Botswana for 2.5 weeks, like I mentioned, and we did 3 demonstrations across that time. And we also spent a lot of time driving across that beautiful country. It is quite a special place to see. And I was saying to Ilse before, I think the last time I visited, I was 12. So to go back, it was really, really wonderful. The first demonstration, we spent our time in Gaborone, and you can see the large circle at the bottom right of the screen. And there we were doing emergency response demonstrations, flights over a few days, different types of flights, and I'll go through each of these in detail. So that was about a week. And then in demonstration number 2, we drove for 16 hours or so, all the way up to the northern border at Chikawe, where we did logistics demonstrations. And those logistics, I don't say medical logistics on purpose, because it was more broad logistics, and to see what was possible in that very rural part of Botswana, whether a drone would be able to do a better job given than traditional vehicles, given the state of the roads and the infrastructure there. And then the third demonstration, we drove all the way back down to the bottom to Jwaneng, where we did a more monitoring and inspection-based demonstration there. So it was about a week in Gaborone, a week in Chikawe, and then a day or so in Jwaneng to do the final demonstration. In terms of what we took with us, this is the a rendering of the Era 3 that we took with us. So this was the aircraft we took. As I said, it's around 19.5 kilograms max takeoff weight, cruising speed of 100 kilometers an hour. In Amsterdam, we can get up to 60 to 75 minutes of flight time. And like I said, it was also incredibly interesting for us to use this aircraft in Botswana and in those conditions where you're flying at around 3,000 feet instead of at sea level, or sometimes maybe even taking off below sea level in Amsterdam. To give you a few of the features that this aircraft has, just so that you can put it into context for yourself, I'm just going to focus on a few of the things. The drone itself communicates with our pilots via LTE, so you need mobile network connection to actually communicate with the drone. However, obviously that isn't going to be possible everywhere in the world, and so we have SATCOM, where if we should lose connection with the drone will automatically switch over to communicate with a satellite, and that way we can actually keep in touch with the drone. It's way more limited than being able to communicate via SATCOM LTE, but it is still a fail-safe that we have. Something that we encountered quite a lot in Botswana, despite its amazing coverage, was losing connection. If that does happen, there is also the fail-safe that the drone will just continue its mission on its own. And that way you know where it is roughly and what it's doing based on when you lost that connection. We have the camera, and that is the Next Vision Nighthawk 2, and that has about a 40 times zoom. It has infrared and thermal technology in it as well, so you can see heat signatures and you can use that at night. Precision landing is if you ask me how the engineers have done this, is an absolutely crazy feature that we can land within 2 or 3 centimeters of any location. And this enables us to land on our docking station, and soon we will have automated charging through this precision landing technology. So that is obviously very, very useful from that autonomy point of view. Some of the features that we will be launching soon, probably early next year or at the end of this year, will be, and these are largely, think of these as more European-based features, even though they would be applicable in Africa, is in Europe, we need a parachute to be able to fly over populated areas. And so that is one of the most complex things that we are currently working on. So the parachute will be integrated soon. With the precision landing, you also want to be able to do fast charging, where you can charge between from 20% to 90% in around 60 minutes. And that obviously then means you don't need people there changing the batteries when you land and want to take off again. A rudder will be integrated into that back fin there, and that enables tighter turns, which means that you can get better visuals when you are loitering over something that you want to view. And last but not least, when it comes to weather and wind in particular, our drone is able to take off in up to 30 knots worth of wind, which is very impressive. And even despite this, there were times where we had to wait for the wind in Botswana. And very European features is that soon it's going to be rain resistant, and we will also be able to operate from minus 10 degrees Celsius to up to 40 degrees Celsius. So this was the aircraft that we took with us to Botswana. And the pilots would be upset if I didn't mention that its official name is Aircraft 006. So it was definitely one of their favorites, and it performed very, very well. So to give you a sense of the demonstrations and just a few of the details from it, in Gaborone we had 3 flights. This was our very first demonstration, and so the first thing we needed to do was run our test flights. And this was really to validate the network strength and also just get a sense of how the aircraft performed in these conditions. It has 2 SIM cards in it from different network providers, so that even if one network provider should fail or run out of signal, you can potentially jump over to the other. So that all went surprisingly well, and we were very, very impressed with both the network coverage and how the aircraft performed, which then meant that we could go into our first BVLOS flight, our beyond visual line of sight flight, towards the South African Botswana border. And that was a 22-kilometer flight. You can see the plan down there at the bottom. This isn't that one. The one that you can see there is the 32-kilometer flight. So we did that flight. We landed. We literally replaced the battery and sent it straight back out again. And if you look closely, you can see some tiny little circles. Those are random, or I would say, loiter points that we did as a demonstration to say, let's focus on this area and fly around it a few times to get a visual on it, zoom in on it, etc. So what we were able to do was track vehicles that were driving out to the border. It's something we've never done before because we were actually flying at roughly the same speed that they were driving. We were able to demonstrate the thermal and zoom capabilities, so seeing the border from still miles away with the camera. And then, as I mentioned, we could go live go-to points during the flight. So that was a huge success for us, and basically gave us the confidence to push the aircraft as we went out throughout the rest of the demonstration. We then drove for 16 hours up to Shakawe, where we faced a completely different application and use case. And here we were testing to see whether we could build a logistics network in the Okavango Delta. And so we wanted to perform flights between 3 different locations to validate the feasibility of whether you could set up a network to deliver things in the Delta. Those things, I use that word because that is still to be defined, what would or wouldn't be delivered there. So if you look at the bottom map on the bottom right-hand corner, that red line was the first BBLOS flight that we did. So that was from Shakawe to Sepopa, and that was a very, very successful flight in those conditions. We did 55 kilometers all the way along that A35 road, and we really, really did push the aircraft. The battery was running low by the time we got to the end, and so the pilots wouldn't have been too confident to do that again had there been any types of light crosswinds or light headwinds. So that's the kind of lessons we learned there at that sort of altitude. But surprisingly, even though we were up on the northern border, the LTE coverage was unbelievable. And I think at certain points in some of the villages where we landed and took off, we had faster LTE rates than we do here in the Netherlands. So it was really, really impressive. That was the first day. The second day was to actually now complete the network in theory. And so we flew from Sepopa to Saronga and then back. And what we did, this was to say that on the bottom side of the Delta, on the west side, the roads are relatively good. But on the east side, they are in far less, they're nowhere near as good condition. And so when people have to go through those different villages, or those different towns, they have to drive all the way up the western border and then all the way down the eastern side to get there. So that's around 180 kilometers or 90 kilometers, depending on where you start. So this is reducing that to a 30 kilometer, 40 kilometer flight that we can do in 35 minutes. So what we did is the one team in Sepopa set the drone off on that blue route, and then I was sent off with a rally driver, pretty much, it felt like, down to Saronga. And I was given a spare battery. And as the drone landed, I swapped the battery out, communicated with the crew that the battery was in the drone. They re-uploaded a mission, and the drone took off and flew itself back. So for me, it was the first time I'd ever done that in those sort of conditions. And it was pretty amazing to see the drone network validated in that way. And as I mentioned earlier, because of high winds, we did have to delay this, and we had to wait for quite a while until the winds dropped. But again, it was a huge success to be able to do that in this part of the world. And then lastly, from the monitoring and inspection demonstration point of view in Chuandeng, we had to do a very, I would say, we didn't have much time to prepare this operation. So that tested the improvisation skills of our pilots to very quickly set up this flight plan. And as you can see by the plan in the bottom right, there was a lot of improvisation as we demonstrated how you can suddenly go here or go there. How many loiters would you like to do around a specific area? Do you want to change your route at any point in time? So it was more to demonstrate the flexibility of the aircraft mid-mission. So we did a 44-kilometer flight over open bush. And like I said, there was very little time to plan. That's one of the lessons we take out of this demonstration, which I will come to later. But in this particular flight, there were multiple connection dropouts where we lost complete connection with the drone. And so you have to either trust that it's going to come back and complete its mission, or at some point along that mission, it's going to come back into LTE coverage, and you can then resume the mission and take control of that drone. So that was also very, very interesting for us to see. And what happened quite by accident is that while testing out the thermal mode, we saw quite a lot of game, and were able to track that, and to basically just get a sense of what was down there, what it was doing, where it was going, etc. So that was the third demonstration that we did. To summarize, and I've gone through it relatively quickly because I can see there are quite a few questions that have piled up, and it's always interesting to have a discussion. We learned a lot while in Botswana. Like I said, the connectivity at times I would argue was better than it is here in the Netherlands. And so that was really, really encouraging. And we found that it was largely linked to the roads and the highways. And so that also means that for the pilots, they had the opportunity using those roads and making sure they knew where the telephone wires were, the pylons were, that they could have multiple rally points that the drone could land at in case something went wrong. So the connectivity was really, really encouraging out there. And Botswana is very flat. So that also made it much simpler for the pilots to not have to navigate around hills, mountains, any high structures like that. So it is a great place to fly from a pure pilot's point of view. Another lesson, and this is not unique to Botswana, it is unique to our industry, I would say, is that the knowledge of what a fixed wing electronic drone can do is incredibly low. So people have very little idea, or most people have very little idea of how far a drone can fly, how much it can carry, what it costs, all of these type of things. And so there is a large responsibility from us who do know to actually educate people and to bring those expectations to a reasonable and realistic level. And then the last lesson was to never compromise on safety and the procedures that we've set in place. Luckily, there were no incidents, nothing went wrong, but we were definitely pushed in the last demonstration to get things going up as quick as possible, to ensure that we can get the maximum flying time. But the pilots were very, very professional and followed procedure to say we need a certain amount of time to plan this mission, make sure we have enough rally points so that if something goes wrong, the drone knows what to do and where to go. And it's something that if you are professional about and insistent on, it will never let you down. And so it was just good to have that lesson reinforced, I suppose. For us, the challenges, and part of the reason why we do these trips is not only to obviously get opportunities to fly and to show our technologies, but is also to come back with a lot of very, very useful data. In Botswana, there's obviously sand and there's dust. And in the Netherlands, we have a lot of rain. So to see how the drone interacts with this dust was fascinating, and also a big challenge, because it is a very different challenge when you open up the drone for maintenance and there is this fine red dust in places you would never imagine it could get to. Another interesting thing that we found is because the sand is often very soft, when the drone lands, the drone knows whether it is flat or whether it is an angle. And some parts of the drone would sink slightly lower, and the drone would still think it was in the air as a result and try to correct itself. So that's something for the engineers to learn about and to say, well, how do we develop the algorithms to know that if the drone is not on a perfectly flat surface, how do we teach it that it doesn't still need to try and correct itself? Heat and height. So as I mentioned, the Netherlands is basically the opposite to Botswana. So to see how the aircraft performed at these altitudes, 3,000 feet, I think we had a real altitude density of 6,000 feet at one point, which is the highest we've ever been. And then to also deal with the heat and what the drone, how the battery performance is impacted by the temperatures we were flying in, which I think were up to 37 degrees at some points. So right on the limit of our 40-degree range. And then lastly, I think one of the future challenges that again, not only Botswana faces, we face the same challenge here in the Netherlands, but is when you bring new technology into a place, how you onboard customers, operators, etc., onto something that is very technical, very specific to a very specific use case, and how you maintain that. There is a lot of learning to be done there, and a lot of work and a lot of mistakes that I imagine will get made there, because it is so unique to in comparison to flying a DJI multi-copter drone just out the back of your car. So those are some of the challenges that we found. And lastly, from the opportunities point of view, it's hard to express how exciting it is to go and fly in a place like Botswana. And I imagine we have been to Benin before, we've been to Botswana before as AV, that there are tons of other African countries that have a similar opportunity or opportunities that Botswana has. The market is new there, and there is a host of potential customers, a host of potential end users and use cases that you can find in a country like Botswana and in other countries throughout Africa. So for us, that's incredibly exciting, but also because there is huge impact that you can make in terms of, especially with something like the medical logistics, reaching rural places and providing access that you wouldn't usually be able to give access to in traditional means. The willingness and the openness to adopt and learn about new drone technology was also incredibly high, and there was a large appetite for it. And I think something that we encounter a lot of friction with here is the regulatory side. So the CAAB, the Civil Aviation Authority, were incredibly supportive, incredibly willing to collaborate, and they understand that BVLOS operations, drones, fixed-wing, long-range drones are coming, and they want to be well positioned to be able to enable that in their context. So that was also a huge opportunity and a massive positive from that. So based on that, I have given what I think should be a broad enough view on the trip. I'm sure there are a host of questions across technical issues to regulatory to logistics to maybe more anecdotal. No question is off limits. So thank you for listening. And yeah, I'm more than happy to answer any questions.
Thank you so much, James. That was awesome. We really appreciate it. So there are questions. I had a question. What was and you may have said this, but what was the highest altitude that you flew?
So let me just go back and get this number for you. And you're going to have to excuse me if I don't understand the exact technicalities of it. But our maximum density altitude that we reached was 6,046 feet. So from what I understand from the pilots, we didn't actually fly at 6,000 feet, but based on the conditions, it basically resembled that, the heat, the humidity, etc. So that was that. In terms of above ground level, we were flying at around between 120, on average 400 feet above ground. So that was what we largely operated at.
Awesome. Thank you. Great. So Kaya had a question. She said, which demonstration of the three was the most challenging and why?
It's a very good question. I would say the second demonstration in the north was definitely the most challenging. And I would say it was because there were a lot of logistical pieces to set up a mock network and to have multiple locations that each need to be scouted out. You need to have safe landing and takeoff zones. You need to coordinate with all the chiefs of all those different villages to make sure that you have the permission to do those flights. And then you actually need everything to be to go according to plan. So I had to be trained and tested on whether I was actually capable of replacing a battery, sending it off, etc. So there were a lot of moving parts in that second demonstration. But at the same time, that is the most exciting one, because that is in effect what we are all about, is setting up a network. And so we could validate that network model in the second demonstration.
Definitely. Thank you so much. So we had a really interesting question from Guy. He said, were you flying in a segregated airspace? Do you see the industry moving toward airspace?
So I think you broke up a bit there, but the question I got, I think you asked, or the question was, were you flying in segregated airspace, and do we see the industry moving that way?
Yes, or if you asked, how do you see the industry moving to shared airspace?
To answer the first question, we weren't flying in segregated airspace. We had very, very good communications with all air traffic control towers in whenever we did fly. And so we were very, very in communications, especially in Gaborone, with all of that. So it wasn't technically segregated. In terms of the future, that's a bit of a crystal ball question. My personal view on it would be that it will become more and more integrated. How that happens is the big question, I suppose. But we see it moving in different directions in different markets and in different approaches. So in the Netherlands, it's different to the way that we see it moving in France, for example, with ADSB in and out and these kind of things, UTM. In Africa, what was really great about that was because the scale was a lot less in terms of air traffic. It is the kind of context where we could, through very, very good communication, be completely safe from that air risk point of view. So to answer that second question directly, I think I do see it moving in that way. I have no idea how long it takes. And so whatever I do say, I would probably double in terms of how long it does actually take, because it's not simple by any means.
Yeah, I have worked on that. It is not simple. So what is kind of question? What is an average flight time on one battery? You said 44 kilometers sounds impressive. Of course, flight time depends on weather conditions and flight height, but a rough number is fine if you have one.
So we have done stress tests and stuff here in Amsterdam, and we've reached an hour, so an over an hour. But on this particular trip, our average flight time was we were doing around 35 minutes. I think that 55-kilometer flight was a 35-minute flight, so 35 around there, and shorter, obviously, for the ones that were shorter.
Great. I think you said that it was pretty you didn't have much wind and that the weather conditions were pretty good. What is the difference between like what did you see was the big difference? Was it from Amsterdam? You know, of course you said it's like complete opposite. What was like the biggest difference in aircraft performance that you saw?
That's a good question. The biggest difference in aircraft performance, I think. So and I'm not saying this because I work for AV, but our pilots tend to be more risk averse and negative, I would say. But they were positively surprised by the aircraft's performance in those conditions. So everything exceeded our expectations of what we thought it would do. I think the biggest downside in the African context is more around your maintenance cycles. So not necessarily performance per se. Obviously, you could draw the graph of how your distances decrease and your times decrease based on altitude, etc. But based on those conditions, based on the dust, based on the heat, your maintenance cycles would have to be a lot less, and so you would need more frequent maintenance. And we saw, for example, the props came away they aged way faster in Botswana than they do here in Amsterdam.
Yeah, harsher conditions. Did you manage to connect with Botswana Flying Labs at all while you were there? Or were you guys pretty full on?
We were, if we weren't planning routes and flying, we were driving. So unfortunately, we didn't. No.
Yeah, yeah, that drive is quite long. How did you go about route selection and route risk assessment?
So that like I said, the education factor in sitting with the different people viewing the demonstrations. In some of them, for example, the demonstration in Gaborone around the emergency responses. We were literally given a list of coordinates to say, okay, we want to see a flight where you go here, 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 here. And that was what we were given. And it was the type of conversation to say, that is possible. But to do that safely, you actually need a lot of planning. And we talked about wagon wheel approaches that the military would use, where you have multiple routes pre-saved in a database to respond to any particular emergency in an area, etc. As an example. So for this particular demonstration, what we did was we basically had discussions around what actually do people want to see, and then we would design a route that was basically safe and enabled them to see the capabilities as much as possible. So the main consideration is really, you need to avoid any obstacles. You want to try and remain in LTE coverage as much as possible. You want to have a route that has safe rally points should something go wrong. And you want to have a route that you are comfortable with, that the drone's performance is actually going to be able to handle. So within that, we didn't necessarily have to worry about too many specific areas that we could or couldn't go to. So it was relatively free, and we had creative license within that. So I'm not answering the question directly, but it wasn't that kind of thing where we had to do a figure of 8 or go to A, B, C, D. We needed to more show the capabilities of the drone and also educate at the same time that you cannot just send it off into the air and then just make it go left, right, up, down.
Yeah, that's great. So Kaya said, you mentioned that the drone rotates on the base platform before takeoff. So you said, does it take off vertically? Is it to make the transition into forward flight easier?
So it does take off vertically, yes. So it takes off vertically and then transitions to fixed wing mode. And that rotation on that disc is to effectively face it into the wind to make that natural uplift more efficient. And so the drone can basically get up in an easier way, in a safer way.
Awesome. So there's another question, and it says that after these episodes are pilots in Botswana, do you already have any roadmap in Africa?
When I say when with the word roadmap, it means I interpret that as specific milestones or goals that we want to hit. So yes, we have goals, and we would love to be more available in Africa. In terms of actual concrete next steps, I would say that is always the challenge. We are obviously very keen and working with Drones for Africa, so that would be a big next step for us, is to actually now onboard them onto our technology, onboard them onto our platform, and start working together there. But I suppose the non-detailed answer to that question is, the more conversations we have, we are having African conversations already, the better, because that's a continent where we really want to fly a lot. And so the short answer is yes, but in a detailed sense, no, we don't have a specific roadmap.
Yeah, I think that kind of actually goes into the next question from Ephraim. He has asked how open are you to work with flying labs, and what should they do to work with you, to work with AV?
So the easiest thing to do is to email me, which is why I put my email address at the end. We are open, but at the same time, I want to manage expectations. We're a team of 50 people developing a brand new aircraft, literally as we speak. And so we always have opportunities to do different things. And it's always around aligning our priorities with whoever we want to work with priorities. So if there is an opportunity, if there is an interesting context, an interesting potential customer, or something to learn that we can both gain from flying together and working together, then of course we will seriously entertain that. But I also can't stand here or sit here and promise that we're going to then be able to partner with every single person on this call.
Yeah, thank you. So Jose asked, and I think he ended up losing internet signal after he asked his question, but what is the maximum flight altitude with a maximum weight to be transported at a distance of 40? So I think you kind of already covered a bit of the altitude as well. Oh, he's coming back. So just letting him back in. You've already covered like some altitude information, distance, and I guess he's looking for what kind of weight goes along with that.
So from an altitude point of view, technically, and now I'm giving you a very this is me sort of repeating what the engineers tell me. Technically, we can fly at any altitude. You just have to take the performance decrease that you get from flying in thinner air, both on duration and on distance. From a payload point of view, we, in these conditions in Amsterdam at sea level, perfect conditions, our payload is 3 kilograms. If you then integrate our parachute that we're about to develop, that then decreases to 2 kilograms because now you have a parachute. In Botswana, we didn't do specific payload tests, but we assume that payload would drop significantly. I would say you would guessing, and I'm probably going to be, if any of our engineers are on the call, they're probably going to come and have a word with me after this. I would say around 1.5 kilograms, 1 kilogram in those conditions in Botswana is what you can expect from a payload. But again, that's something that we would have to test and actually validate, whether it is higher or lower.
Thank you. That definitely helps give a ballpark range. So Alexander has asked, he's with the Swedish Sea Rescue. He says that he was wondering if you could share some insights, difficulties concerning the ground control software.
Ooh, the ground control software. So I'm assuming he means the software, the flight operation software, and setting that up.
I think probably.
Say that again.
Probably
Yes. Okay.
If there's any.
Yes. So I can't speak from experience since I'm not a pilot and I don't use the software. But from our point of view, from what I hear the pilots say, the challenges are it's when we talk about first response and rapid response, the mind or the picture that people have in their mind is taking a remote control, launching a drone from a docking station and sending it off manually to an area. Now that isn't possible with a fixed wing VTOL aircraft that's flying at 100 kilometers an hour. It's just too dangerous to manually fly an aircraft in fixed wing mode at 100 kilometers an hour. So the challenge is less around software and bugs and functionality and those sorts of things. The challenge is more around having enough predetermined flight routes in an area that you can then upload instantly and then launch and then set live go-to points during that operation. So I know from conversations with sea rescue in the UK, for example, that when there is a sea rescue operation at sea and someone is lost at sea, how people behave when lost in the ocean is relatively predictable. And so there is ways to automate flight routes that have a high probability of picking those people up. So the challenge would be more around having enough docking stations positioned in the right places and the missions pre-uploaded to activate rapidly than around the software itself, I think. It's a very long answer. I'm sorry if that was a long answer.
It's very interesting. Having done a lot of troubleshooting in my career, I appreciated Alexander's question as so that was the last question we had. Unless anyone else has a question, feel free to raise your hand or put in the chat. We have a few more minutes if anyone has any more questions or comments, anything you'd like to say. But we really appreciate your time, James, and all of this valuable information. So one thing on my side, just wondering about kind of the technology that you said is developing with your engineers and for your drones. So are you already, I know that you have the Era 3 and that's what you were flying, and you said that is the Era 4 encompassing all of the new specifics that you mentioned earlier?
Yes, so the Era 4 will fundamentally at its core be the same aircraft as Era 3 in terms of all its base specifications. The main difference will be that it is more European proof in the sense that it will have a parachute integrated, which enables us to fly over cities. And I see the question about the regulations. The parachute will be integrated. Then there is a separate process to actually get that certified by EASA. That process is, the best word is complex. And so a timeline on that is very difficult to give, but we expect to have that certification next year, which will enable us to fly over populated areas. So it will be, the parachute will be a fundamental difference. The waterproofness will be a fundamental difference, and the ability to fly below 0 degrees up to -10 degrees Celsius will be the big differences. There will be minor changes, improved SATCOM, the rudders, all of these sorts of things. But the goal is to effectively increase our autonomy and then also increase our operational window.
Thank you so much. Well, if there aren't any questions or comments, we just want to say thank you again, James. It's been hugely beneficial for all of us to hear. And I did put AV's website in the chat for anyone to check out. And then also just for the rest of our purpose, AV does a lot of drones for good work. And so please take your time, everyone, to check them out. Go and do some research, and they have a great website. So I really would suggest you go and take a look. And then, as James said, he's put his email in his PowerPoint, his slide deck, and this will be on the this recording will be uploaded in the next couple of days. So if anyone has any questions or anything else, then please feel free to contact me, Kaya, or James. So thank you so much, and we really appreciate your time and effort that you put into sharing about your flights in Botswana. It was absolutely amazing.
No, pleasure. Thank you for having me, and I hope it was useful for everybody.
Thank you. Oh, and if you do have one like a time,
absolutely.
just quickly, Alec did ask regarding fail-safe behaviors. He said, I suppose you have tried several. What are the main benefits, drawbacks with the behaviors you described earlier, if you don't mind?
So with regarding the fail-safe behaviors, yeah, so I think, funnily enough, I think to answer this very briefly, the technology is tested, and so in terms of the hardware that we use, we're incredibly confident in the hardware and its ability to endure because we've tested it. And so most of the challenges we see don't sit on a hardware sense; it more sits on the challenges that you face from other air traffic, for example. So coordinating with air traffic control towers, coordinating with the CAA, and mitigating risks operationally are actually where you can have the most impact. But obviously, from a fail-safe point of view, from a communication point, we have the dual LTE, we have the SATCOM, and then we have the return to landing logic in the drone, etc. So that's a list that is as long as my arm in terms of all the mitigations we have to have. I know it's not a direct answer, but it's one that needs longer than a few minutes. I can leave my email address in the chat, I suppose, if people are asking for it. Is that fine?
Oh yes, please go for it.
Okay,
if you'd like
sure.
to put that, if you don't mind. Yeah, that's great. Thank you all. Cool. Well, thank you. Okay, that is the last question. So please feel free, everybody, to get in touch with any of us at any time. So thank you, James, for your presentation. Thanks everyone for joining. Please go ahead and take down James's email address, and hope you have a great rest of your morning or afternoon. I think afternoon in my case. So thank you, guys.
Thank you, everybody.
Take care.
Bye.